The universe has always felt like a story too big to grasp, a tale written in starlight and shadow that stretches beyond our wildest dreams. But what if the edges of that story, the farthest reaches we thought we'd never touch, are suddenly within our sight? What if those edges aren't just a distant horizon but a jagged, living boundary that whispers secrets we're not ready to hear? The James Webb Space Telescope, humanity's most ambitious eye on the cosmos, has just peered into the abyss and brought back images that don't just challenge our understanding. They shatter it. This isn't about distant stars or faint galaxies. This is about seeing something so vast, so strange, that it forces us to question everything we thought we knew about the universe. It's not empty out there. It's not silent. It's crowded, chaotic, and pulling at us in ways that make the heart race and the mind reel. What NASA found at the edge of the observable universe isn't just a discovery. It's a dare to rethink reality itself. Imagine standing at the edge of a cliff, staring into a void so deep it swallows light itself. For decades, we thought the edge of the universe was something like that, a blurry, unreachable horizon where time and space faded into a haze. Cosmologists called it the observable limit, a boundary set not by walls but by the finite speed of light and the universe's 13.8 billion-year age. Beyond it, we assumed, was just more of the same, a vast, uniform expanse of galaxies thinning out into nothingness. But the James Webb Space Telescope, with its golden mirrors gleaming like a cosmic lighthouse, has turned that assumption upside down. Its latest images, released in early 2025, show something no one expected: structure. Not just faint smudges of light, but vibrant, fully formed galaxies, cosmic metropolises, clustered together in ways that defy every model we've built. These aren't the sparse, primitive star clusters we predicted for the universe's infancy. They're bustling hubs of light and matter, blazing with stars that shouldn't exist yet, not when the universe was barely 300 million years old. It's as if we walked into a city that was built before its architects were born. The data is staggering. The Cosmos Web Survey, a massive mapping project led by astronomers like Caitlin Casey, has cataloged nearly 800,000 galaxies in unprecedented detail. That's 10 times more than the Hubble Space Telescope ever suggested existed in the early universe. These galaxies aren't just numerous, they're impossibly advanced. They're rich with metals, the heavy elements forged in the hearts of stars over billions of years. Yet these galaxies had barely a fraction of that time to form. Some are so massive they rival our own Milky Way, with stars numbering in the billions. Caitlin's words still echo in my mind. The universe was producing too much light too early. It had only about 400 million years to form something like a billion solar masses of stars. We just don't know how to make that happen. It's like finding a library full of books written before the invention of paper. How do you explain that? How do you make sense of a universe that seems to have outpaced time itself? Then there's the black holes, monsters lurking at the hearts of these ancient galaxies. One, found in a galaxy called UHZ-1, weighs between 10 and 100 million times the mass of our Sun. That's not just big. It's unthinkable for a universe that was only 470 million years old. Black holes take time to grow, feeding on gas and stars over eons, yet this one was already a titan when the cosmos was still in its cradle. Some scientists are now whispering about a radical idea: direct collapse. What if, in the universe's chaotic first moments, massive clouds of primordial gas didn't bother forming stars? What if they skipped the slow dance of stellar birth and death and collapsed straight into black holes? It's a theory that feels like a plot twist in a cosmic novel, one that forces us to rewrite the opening chapters of creation. But it's not just the black holes or the galaxies that have astronomers on edge. It's the patterns, the unsettling, uneven structure of the universe itself. The James Webb didn't just find more galaxies. It found them arranged in ways that make no sense. The universe, we thought, was supposed to be symmetrical, a smooth canvas of matter stretched evenly across space. But the telescope's deep-field images revealed density asymmetries, clusters of galaxies clumped together in some regions, sparse in others, as if the cosmos itself is lopsided. At the largest scales, where light has traveled for nearly 14 billion years to reach us, these asymmetries are screaming something is wrong. The data hints at a gravitational pull, a force tugging at galaxy clusters from beyond the observable edge. NASA researchers have tracked this motion called dark flow out to 2.5 billion light-years, and the pattern doesn't fade. It's as if something massive, something we can't see, is yanking at the fabric of spacetime, drawing galaxies toward it like moths to a flame. What could it be? A hidden structure? A cosmic void so vast it warps reality? Or something stranger, something that doesn't fit into any equation we've written? This isn't just about galaxies or black holes, it's about the shape of existence itself. For years, we've relied on the cosmic microwave background, that faint glow from the Big Bang's afterbirth, to tell us the universe is uniform. But even that story is cracking. The Planck satellite, years ago, found anomalies. A mysterious cold spot, temperature patterns dubbed the axis of evil, by scientists with a flair for drama. These quirks suggested the universe might not be as even as we thought. Now, the James Webb's galaxy maps are aligning with those same anomalies, as if the telescope and the satellite are telling the same unsettling tale. The Hercules Corona Borealis Great Wall, a structure so massive it spans 10 billion light-years, looms as a testament to this cosmic imbalance. It's not just big, it's impossible. Standard models say gravity hasn't had time to build something that stretches across a tenth of the observable universe. Yet there it is, a cosmic behemoth that laughs at our predictions. As I sit with these discoveries, I can't help but feel a shiver of awe and unease. The universe isn't just bigger or busier than we thought. It's alive in ways we never imagined. It's not a passive backdrop to our existence. It's a dynamic, uneven tapestry, woven with forces we can't yet name. The edge we thought was a limit might be a doorway, a threshold to something or somewhere else. What if the pull we're seeing, the asymmetries and impossible structures, are hints of a larger reality? What if our universe is just one bubble in a cosmic sea, brushing against others in ways we're only beginning to detect? The James Webb Space Telescope hasn't just shown us the edge of the universe. It's shown us that the edge might not be an end, but a beginning. And that thought, that possibility, makes my heart race as much as it makes my head spin. The universe has never felt so alive, so restless, as it does now. The James Webb Space Telescope has peeled back the curtain on a cosmos that refuses to play by our rules, and the more we see, the less we understand. It's not just the galaxies or the black holes that have us reeling. It's the way the universe seems to bend and twist, as if it's hiding something just out of reach. The edge we thought we'd found isn't a neat boundary. It's a jagged, pulsating frontier, alive with forces we can't name and structures that shouldn't exist. As we stare into the abyss, it's staring back, whispering questions that make our hearts pound. What's pulling at us from beyond? Why is the universe lopsided? And what if the strange patterns we're seeing are echoes of something even bigger, something that could rewrite not just our place in the cosmos, but the very nature of reality? Let's step back into the chaos of the early universe, where the James Webb's gaze has uncovered a story that feels more like a fever dream than science. The galaxies it's mapped, those impossible star-packed cities, aren't just too big or too bright for their time. They're clustered in ways that defy the smooth, even spread we expected from the Big Bang. We used to think the universe expanded like a balloon, inflating uniformly in all directions. But the telescope's data paints a different picture. One side of the balloon seems to stretch faster, pulling galaxies into dense knots while leaving other regions eerily sparse. These density asymmetries, as astronomers call them, are like cracks in the foundation of our cosmic understanding. They suggest the universe isn't just uneven. It's being shaped by something we can't see, something massive enough to tug entire galaxy clusters toward it. They suggest the universe isn't just uneven, it's being shaped by something we can't see, something massive enough to tug entire galaxy clusters toward it. NASA's researchers have traced this motion, this dark flow, across 2.5 billion light-years, and it doesn't stop. It's as if the universe is a vast ocean, and we've just noticed a current pulling everything in one direction, toward what we don't know. This invisible pull, this unseen attractor, is where the mystery deepens. Imagine you're on a ship, drifting across a sea that's supposed to be endless, only to feel a tide dragging you toward an unknown shore. That's what the James Webb's data feels like. Some scientists speculate it could be a massive structure, a supercluster or void so vast it warps the fabric of spacetime itself. Others dare to dream bigger, wondering if it's a gravitational echo from beyond our observable universe, a hint of another cosmos brushing against our own. The idea sends a shiver down my spine, not just because it's strange, but because it feels possible. The Planck satellite, years ago, found clues in the cosmic microwave background, those faint ripples from the Big Bang, that hinted at a universe that wasn't quite right. A cold spot, colder than it should be. Temperature patterns that lined up in ways they shouldn't, nicknamed the axis of evil for their defiance of our models. Now, the James Webb's galaxy maps are echoing those same anomalies, as if the universe is trying to tell us something across billions of years and countless light years. Then there's the Hercules Corona Borealis Great Wall, a structure so enormous it feels like a myth. Spanning over 10 billion light-years, it's not just a cluster of galaxies. It's a cosmic leviathan, stretching across a tenth of the observable universe. When astronomers updated its measurements in April 2025, they found it was even bigger than they'd feared, defying every rule of how matter should clump together. Gravity, we thought, needed billions of years to sculpt structures this vast. Yet the universe was only a fraction of that age when this behemoth began to form. John Hakala, one of the researchers studying it, said something that still haunts me. Our sample isn't large enough to place an upper limit on its size. It's larger than anything we might compare it to. It's like finding a mountain range that keeps growing the more you explore it, with no peak in sight. Some scientists argue the structure could only exist if the universe's early expansion, cosmic inflation, allowed matter to clump on scales we never imagined. Others call it a fluke, a statistical quirk that just happens to be in our line of sight. But a few, the boldest among them, whisper a wilder idea. Could this be a scar from a previous universe, a remnant of a cosmic cycle we can't yet comprehend? The thought of a cyclical universe, one that dies and is reborn, feels like stepping into a story where time itself loops back on itself. It's not just the Great Wall that fuels these ideas. It's the way the universe seems to play with time. When astronomers peer at the farthest objects, they're looking back to the dawn of existence, and what they're finding doesn't add up. Supernovae, those explosive deaths of stars, should follow predictable patterns as their light stretches across billions of years. But the James Webb has caught some that don't behave. Their light curves, the way their brightness rises and falls, show subtle deviations from what Einstein's relativity predicts. It's as if time itself flowed differently at the universe's edge, ticking at a rhythm we can't quite match. This isn't just a quirk. It's a crack in our understanding of how the cosmos works. If time was less predictable in the early universe, it could mean the expansion of space wasn't as smooth as we thought. It could mean the rules of physics, the ones we've built our entire understanding on, shift when you get far enough away. This idea ties into something even more troubling, the Hubble tension. For years, we've known that measurements of the universe's expansion rate don't agree. The Planck satellite, looking at the cosmic microwave background, pegs the rate at about 67.4 kilometers per second per megaparsec. But when we measure nearby galaxies, the number jumps to 73. A 9% difference might sound small, but in a universe built on precision, it's a chasm. The James Webb's findings are starting to hint that this tension isn't just a measurement error. It's a sign of something deeper. What if the universe's expansion isn't uniform? What if time and space stretch differently depending on where you stand? The thought makes my head spin, but it also fills me with a strange kind of wonder. We've always assumed we live in a universe that's orderly, predictable, average. But what if we're in something far stranger? A cosmos where time bends, where invisible forces pull, where the edges pulse with secrets we're only beginning to glimpse. As I think about these discoveries, I can't shake the feeling that we're standing at a crossroads. The James Webb Space Telescope isn't just showing us galaxies or black holes. It's showing us a universe that's alive, uneven, and full of mysteries that tug at our imagination. The cold spot in the cosmic microwave background, once a curiosity, is now gaining new weight. Some say it's a super void, a vast emptiness that warps the light passing through it. Others, braver or perhaps wilder, suggest it could be a scar from another universe, a place where our reality brushed against something else in a cosmic dance we can't yet understand. The idea of a multiverse, once the stuff of science fiction, feels closer than ever. And as we keep looking, as telescopes like the upcoming Nancy Grace Roman Space Telescope join the hunt, I can't help but wonder, what else is out there, just beyond our sight, waiting to rewrite the story we thought we knew? The universe is no longer the quiet, orderly place we once imagined. It's a wild, untamed expanse, full of secrets that pulse and shimmer at its edges. The James Webb Space Telescope has shown us a cosmos that's not just vast but alive, a place where time bends, where galaxies defy logic, and where invisible forces tug at the fabric of reality itself. As we stand on this precipice, staring into a universe that feels more like a living story than a static map, the questions grow louder. What lies beyond the edge we can see? Are we just one chapter in a much larger tale? And what does it mean to live in a cosmos that refuses to fit our expectations? The answers, if they exist, are still out there, waiting in the starlight, but every new discovery pulls us closer to a truth that feels both exhilarating and terrifying. The deeper we look, the more the universe seems to unravel. The cosmic microwave background, that faint echo of the Big Bang's first light, has always been our guide to the universe's infancy. But the James Webb's findings, paired with earlier clues from the Planck satellite, are painting a picture that's anything but simple. The cold spot, that mysterious patch of the cosmos colder than it should be, isn't just a curiosity anymore. Some astronomers think it's a super void, a vast emptiness that warps the light passing through it, like a shadow cast across the universe. Others, though, dare to imagine something wilder. A bubble scar, a place where our universe might have grazed another in a cosmic collision. The idea of a multiverse, a reality where our cosmos is just one of many, floating like bubbles in an infinite foam, feels less like science fiction with every passing day. The James Webb's galaxy maps, aligning with those strange Planck anomalies, hint at a universe that's not just lopsided but connected to something bigger, something we can't yet see. And then there are the fractal patterns, the faint whispers of structure in the cosmic microwave background that some researchers call topological relics. These aren't just random noise. They're like scars in the fabric of space-time, etched during the universe's violent birth. Imagine the Big Bang not as a gentle unfolding but as a shattering, like glass cracking under unimaginable pressure. These relics, these cosmic strings, could be the remnants of that moment, threads of energy so dense they bend the rules of physics. Future observatories like the Laser Interferometer Space Antenna or LISA might one day catch the faint ripples of ancient gravitational waves, echoes from the first fraction of a second after the Big Bang. If they do, those ripples could tell us things the light can't. About the conditions of a universe so young it hadn't yet learned how to shine. The thought makes my heart race. We're not just looking at the universe's past. We're on the verge of hearing it, feeling its first tremors. But it's not just the past that's rewriting itself. It's the present, too. The Hubble tension, that stubborn mismatch between the universe's early and late expansion rates, keeps nagging at us. The Planck satellite says one thing, 67.4 kilometers per second per megaparsec, while nearby galaxy measurements say another, 73. This isn't just a math problem. It's a clue that the universe might not expand the same way everywhere. The James Webb's data, with its hints of time dilation that doesn't quite match Einstein's predictions, suggests something even stranger. Time itself might not flow the same way at the universe's edge. Supernovae, those cosmic explosions, are ticking to a different rhythm, their light curves bending in ways our models can't explain. It's as if the clocks out there, billions of light-years away, are running on a different schedule, challenging everything we thought we knew about the universe's heartbeat. This brings us to the heart of the mystery. What are we really part of? For so long, we thought the universe was a single, sprawling canvas, 94 billion light-years across, shaped by dark matter, dark energy, and the ordinary stuff of stars and planets. But the James Webb's discoveries are forcing us to think bigger. The Hercules Corona Borealis Great Wall, that impossible structure stretching 10 billion light-years, isn't just a challenge to our models. It's a question mark written across the sky. How could something so massive form in a universe so young? Some say it's a fluke, a rare alignment that makes it look bigger than it is. Others argue it's proof that cosmic inflation, the rapid expansion after the Big Bang, played by rules we don't yet understand. And then there are those who wonder if it's a relic, a piece of a universe that came before ours, carried forward like driftwood on a cosmic tide. As we grapple with these ideas, new telescopes are joining the hunt. The Nancy Grace Roman Space Telescope, set to launch soon, will map billions of galaxies, building 3D models of the cosmos with a precision we've never had before. It's not just about seeing farther. It's about understanding the shape of the universe, its curves and edges, its hidden currents. What might we find? Maybe hints of those primordial gravitational waves, ripples that could reveal the universe's first moments. Maybe evidence of quantum limits, places where space-time itself hits a boundary, like a computer running out of memory. Or maybe, just maybe, signs that our universe is one of many, a single bubble in a vast multiverse, brushing against others in ways that leave faint scars like the cold spot or the Great Wall. Each discovery feels like a step toward something larger, something that makes our place in the cosmos feel both smaller and more profound. Standing here, in the shadow of these revelations, I can't help but feel a mix of awe and humility. We used to think the universe was mostly empty, a vast desert of light and dust.